Hello everyone, welcome back to my reports. This is the final report for the Capstone project at Indiana Tech College of Engineering. So the contents I'm going to be going over in this report are the project summary, design technical specifications, the final design, the final prototype performance, obstacles and constraints, budget, and my closing thoughts on this project. The project summary, the project that I've been working on is an analog effects pedal designed to be used with guitars. A single effects pedal usually costs around $70, but can become of a magnitude more expensive, going all the way up to $400 for a single analog effect. Multi-effects pedals are even more of a magnitude more expensive because I've seen some of them start at 350. They go all the way up to I've seen 1200. I've seen even higher than that. The digital effects, they help out with the cost of these, but digital effects do sound different and they're known to be pretty unreliable when compared to analog effects. Having all these effects in one unit would also eliminate the need for extra cabling. Uh, I believe that I'm capable of creating a cost-effective and reliable pedal that can be comparable to high-end analog pedals that are selling for $1,000+ for less than $100. Initially, I planned on having 4 analog effects in this, as well as a power system and audio input system. The 4 effects I chose were a fuzz, chorus, modulation, and a reverb delay. The PCB and housing, these subsystems, they were all required to fit inside of the housing, and all of these subsystems needed to fit on a PCB that had the maximum constraints of 103.5 millimeters by 182 millimeters. The enclosure for the pedal is a maximum of 188 millimeters by 119 millimeters by 37.5 millimeters. The power and audio hardware that I've been using in it are the 5.5 barrel jacks. They're pretty common. The audio hardware for the signal is just the common 1/4-inch stereo jack. The entire system is going to operate on 9 volts because that's what most of the pedals that are used out in the market are 9 volts, so you'll be able to find power supplies for them. The 3P-DT stomp switches are going to be used in the system to allow for signal bypassing, so even though you don't have the system powered, the sound signal will still travel through the device. The final design, this is the PCB. I designed the board and it fell within the constraints that I had set at 95 millimeters by 175 millimeters. The software that I used to design the board itself is a €10, $15 program called Fritzing. They even offer a fabrication partnership with another company. I can't remember the name of it. And I decided to go with this Fritzing software over the Cadence because it's a little bit more user-friendly and easier to learn. And you can see over on the right-hand side the wire diagram that has the fuzz circuit, chorus circuit, modulation, audio circuit, and power circuit. And then below that is the board itself that I had designed, and it shows all the other subsystems on that board as well. Here's a larger version of that. The final design, the power circuit. I decided on the 9-volt system since it's one of the most popular voltages used for pedal supplies. I created the final design by using a strip board with an on-off switch that had a positive and negative input going to each of the effects. Once the system is energized, I added an indicator LED in the center of the pedal that will light up to let you know that there is power applied. And you can look on the right-hand side and you'll see the version 2 power system without the shrink wrap that I put on there, and then it tucked away in the box. The final design for the audio and input circuit. Version 1 was basically the system that I used to test all the designed effects that I had to test to see if they worked. Version 2 is a total of 5 components. It has 2 of the audio inputs and then 3 of the 3DPT foot switches. And those types of switches that I mentioned before, they allow for signal bypass even if they're not engaged. The fuzz effect circuit had 3 different layouts of the same design. The first one was my test circuit. The V2 was the strip board that I used, and V3 was a blank of the black carbon fuzz. It is a clone of another fuzz system that I based my initial system off of. The reason why I had to go with uh, the pre-made project board was because I wasn't able to get the PCB that I wanted made, so I had to come up with a backup plan. I originally tried the strip boards, but the only effect that I could get to fit on those boards was the fuzz effect. All the other ones, if I tried making the effects on those boards, none of the effects would have fit inside of the enclosure. Here's a close-up of that. And the course effect circuit. V1 was the effect that I had tested. It contained the Panasonic MN3007, and that required a negative voltage. On my initial testing with the fuzz and that, it caused a weird hum inside of the amplifier. So I was trying to find a positive voltage counterpart to that chip, and I ended up finding the V3207, which is basically the same Panasonic chip, but it just uses a positive power supply. And the V2 board uses the V2 board is very close to the board that I had, but instead of it using the Panasonic chip, it uses the V3207. And here's a close-up of that. And on the next slide, you can see that basically the entire circuit was the same. All the ICs were the same besides these two. And it added two more potentiometers that were put in spots that just normal resistors would be on the other one. The modulation circuit. The modulation circuit is the original test circuit that I used for this very version. So version 2 is the same circuit as version 1. I based my original circuit off of this actual board. So since I wasn't able to get the PCB that I needed, I just went ahead and next day shipped this PCB so I could get my design made. Here's a close-up of that. And the housing is it's a die-cast aluminum enclosure from Tata. It's 188 millimeters by 19 by 37.5 millimeters. I used resin to actually color it, and temporary tattoos to add some of the decals to it to decorate it. I used two different metric step bits to make holes for mounting components. The reason why I did that was because I needed a little bit more space for when I was putting the mounting hardware to the potentiometers, the switches, and the stomp switches. The LEDs required a 4 millimeter hole, the toggle switches and potentiometers required a 6.5 millimeter, the audio jack required a 9.5 millimeter hole, and the stomp switches required the 12 millimeter holes. And here are the steps that I went through in my design process. And I also didn't order any of the potentiometers because I really wanted to design my own. The potentiometers that you see down there that were printed, or not the potentiometers, but the potentiometer knobs that were printed, were found on Thingiverse. It's a fair use STL file sharing website. And I made those to go on the pedal. And this right here is the completed pedal prototype. It contains 3 of the 4 effects that were initially proposed. This was because of the size constraints with the original board, and since I'm not using my original prototype board, it kind of made the spacing issue even more, and you'll see that when I do the video presentation. All right, let's check out that demo. And, ooh, okay. So this light right here, that means I put it on the center of the astronaut just to show that it has life. But the red light means that power is applied. All right, now let's try the fuzz. That sounds awesome. All right, now let's try the chorus. Oh, okay, so maybe the... Oh, okay. So I think I might have these LEDs wired weird, because this one right here is supposed to show the rate,
And this one right here is just supposed to show that it has power that's applied. Ooh, wobbly. Alright, well, let's move on. That's fun, though. Okay. That's pretty cool. Draw it like a heartbeat. Okay, there we go. Now, let's do one of my favorite effects. This is the phaser. Spacey. Now let's try it all together. This is probably not going to sound very good. That does sound kind of cool.
The obstacles and constraints that I ran into, the first obstacle was actually obtaining the ICs. I had to order 4 of them from on the other side of the planet. 2 of them were from Germany, and the other 2 had to come from Indonesia. That kind of threw a wrench in the gears of getting my circuits tested. I was only really able to test the fuzz circuit and the modulation. The next obstacles were in weeks 9 and 10. This was actually due to the constraint issues that I talked about. The spacing issue of getting that delay and reverb effect onto the board wasn't going to happen because I needed to stay inside the constraint that I had set. And the last obstacle was actually trying to come up with a replacement for the prototype. Since I wasn't able to get the PCB design printed that I wanted, I had to get everything ordered and soldered so that I could have a prototype to show and do my report on. But I was able to get it running, which is all good. The budget. The latest revision has a final cost of $85.87 per unit, and the previous unit cost was $90.24. But this raised my actual total cost of around $141.95. The actual cost reflects mostly due to the shipping and the component quantities. So I wasn't just able to order one 470 picofarad capacitor. I had to order them in sets of 10, and that went most of the components that I had. I think that this type of pedal would probably sell for around 400 to 500 if I could use my own PCB prototype. And I also have a number of components left, so I could probably only spend money on ordering the PCB and housing and still have enough to make 2 more of these pedals. In conclusion, besides the performance of the pedal, I think that hobbyists and professionals would really appreciate to have this pedal in their collection because of the size, the number of effects that it has, and just the way it looks. I believe that I found a pretty cost-effective way to create and design future guitar pedals, and I think that this analog multi-effects pedal performed outstanding. It sounded very, very good. I'd like to make a revision of this pedal so that it can use my own PCB that I designed. And I would also like to find a way, probably if I would get, I could probably get this last effect on there if I used a 3-layer board. But since I was only working with 2 layers, it really didn't help me with the size constraints. And here are some of the references that I used. You can see that we have links to the fuzz effect, coarse effect, and modulation effect, and the enclosure that I used, and the video to my demo. And thank you everyone for watching. This has been a great project, and I hope to do more things like this in the future. Bye everyone.